Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of rational function. As per the problem, sketch the function f at x equals negative 2 over x plus 4 and write the intervals where the slope is increasing and decreasing. First, we have to sketch this given function f at x, and for that we have to identify the key features of the graph of this function. The first key feature is the intercept. So let's start with x-intercept. We can find the x-intercept of this function by setting the function value equal to 0 and solving for x. Next, we can cross multiply the denominator x plus 4 to the left side. 0 times x plus 4 is equal to 0. There is no x term in this equation. That means this function has no x-intercept. Next, we can find the y-intercept. For y-intercept, we should sub in x as 0 in the given function. Zero plus 4 is equal to 4. We get negative 2 over 4. This fraction can be reduced to 1 over 2. So the y-intercept is negative 1 over 2. We can write it as an ordered pair as 0, negative 1 over 2. Next, we can find the asymptotes for this function. Let's start with the horizontal asymptote. The degree of the numerator in this function is 0 because there is no x term in the numerator. The degree of the denominator is equal to 1 because there is an x term in the denominator. Since the degree of the numerator is less than the degree of the denominator, the horizontal asymptote for this function is at y equals 0 or the x-axis. There is a very important concept we need to understand and memorize to solve this type of problem. Next, we can find the vertical asymptote. To find the vertical asymptote, we should set the denominator expression equal to 0 and solve for x. I get x equals negative 4. This is the vertical asymptote for this function. Next, we should find the end behaviors for these two asymptotes. Let's start with the horizontal asymptote. For horizontal asymptote, the end behavior is written like this. We have to do the check on the left and the right side of the x-axis. For the left side, we should use a big negative number like negative 100. We should sub in x as negative 100 in the given function equation. This expression has a positive value. We should compare this value with 0 because the horizontal asymptote exists at y equals 0. Since this positive value will be greater than 0, that means the graph approaches the horizontal asymptote on the left side from above. So y approaches 0 plus. Next, we can do the test on the right side of the x-axis. We should sub in x as a big positive number. We can use x equals 100. This fraction has a negative value. A negative value will be less than 0. That's why the graph approaches the horizontal asymptote from below on the right side. So this is the end behavior for the horizontal asymptote. Now we can find the end behavior for the vertical asymptote. The vertical asymptote is at -4. We have to find whether y approaches positive or negative infinity on the left side and the right side of this vertical asymptote. Let's start with the check on the left side. We should use an x value very close to -4, but on its left side, we can use x value -4.01. This fraction has a positive value. Therefore, on the left side of the vertical asymptote, y approaches positive infinity. Next, we can find the end behavior on the right side. We should use an x value very close to -4, but on its right side, we can use x equals -3.99. This fraction has a negative value. That means on the right side of the vertical asymptote, y approaches negative infinity. So these are the key properties of the graph of this rational function. We can use these properties to sketch the function. Let's start with the intercepts. There is no x-intercept. The y-intercept is at -half. The horizontal asymptote is on the x-axis. The vertical asymptote is at -4. Now we can show the end behaviors. On the left side, the function approaches the horizontal asymptote from above. On the right side, the function approaches the horizontal asymptote from below. On the left side of the vertical asymptote, the function approaches positive infinity. On the right side of the vertical asymptote, the function approaches negative infinity. Now we can join these end behaviors. So this can be the sketch of this function. Next, we have to write the intervals where the slope is increasing and decreasing. For that, we should draw tangent lines on these curves. Let's start with the curve on the top left corner. We can show the tangent lines like this. We can see all of these tangent lines have positive slope, and as we go from left to right along the curve, the slope of the tangent lines increases. So the interval where the slope is increasing is from -infinity to -4. We can also write this interval as next. We should analyze the other curve in the bottom right corner. We should start by drawing tangent lines to this curve. These tangent lines have positive slope because these tangent lines are sloping upward from left to right. As we go along the curve from left to right, the slope of these tangent lines is decreasing. These tangent lines are becoming flatter. That means the interval where the slope is decreasing for this function is from -4 to +infinity. We can also write this interval as x is greater than -4. So these are the intervals where the slope for this function is increasing and decreasing. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.